Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my Pennsylvania A3 switcher locomotive this week and I'm going to make the steam chests that sit on top of the cylinders. They house the valve and they help direct the steam into the ports to make the pistons move. So let's go. Previously we finished up the cylinder castings. Now it's time to make the steam chest, which is a piece that sits on top and contains the slide valves. Let's start with the drawings. I made this here because I actually modified this steam chest from the original drawings, as you may recall from the previous video. There's two separate centerline references now. That's going to be important. And this top dimension, the 547, is the same as the original, but this lower one I've modified in order to match the smaller dimensions that I have on my steam cylinder castings. To make these steam chests, I've got this piece that I found in the scrap bin, which happens to be just about the perfect size. As is generally the case around here, this project will of course start on the bandsaw. I'm going to rough cut these two pieces to shape for the two steam chests. I'll note that the steam chests are the same in every way internally as the original design. I've only modified one of the exterior dimensions slightly. So the performance of the locomotive remains unchanged and the bolt pattern and everything remains the same. I've only made a small cosmetic change to the steam chests to make them match my slightly off-size castings. I'm cleaning these up using kind of a cheater method. I'm not doing a full proper squaring of stock here because that isn't necessary and takes a lot longer. If you're interested in the full proper way to square up stock, I have a video on that in my Mill Skills playlist. But if you just need the sides of the piece to be basically mostly square and cleaned up and brought to dimension, this is a quicker way to do it. Make two parallel sides, then hold those sides in the vise, and then side mill the ends, and then you can do an end mill or a face mill across the top to bring those down to dimension. Again, you won't end up with a piece that's as perfectly square as it can be using this method, but it's a whole lot quicker and most of the time good enough. Also of note, I'm taking very light cuts on most of the dimensions because this stock that I'm using is actually nominally the final size for the steam chest in a couple of dimensions, so I can take very light cuts, still end up within tolerance on those dimensions, and end up with faces that look much nicer and, importantly, are sealing surfaces, so they do have to be machined. With both of those blanks brought to this point, now I can blue up and mark the ends for the valve gland feature. The valve gland on most steam engines is a two-piece arrangement, something that bolts to the steam chest. However, in Kozo's design for this model, he has them integrated into one component. So we're going to be turning a boss directly on the ends of these steam chest pieces. So I'm marking with the surface plate where the centers of those need to be. They're slightly off-center, as you'll see, which is important. The valve rod is actually off-center on this locomotive so that it lines up properly with the running gear below it. I will center punch those with a very small punch mark for accuracy, but I do need them to be a little bit larger than this, so I will now come in and enlarge them with a bigger punch. A smaller punch is going to be more accurate and it's more easy to get accurately on your crosshairs, but then a bigger punch is going to be necessary, as you'll see, for the lathe setup that is to come. But I'm happy with those, so let's go over to the lathe. As I said, this feature is off-center, so we can't just dial in this square piece on the lathe and start turning. I need to get that center punch mark that we just made centered on the axis of the lathe. Here's an easy way to do that I like very much. You've seen it a lot on my channel. I use the punch mark to support a dead center with my live center on the back, and then bring in my dial indicator and dial in the dead center just as though it was a piece of stock in the forejaw. This is a really accurate and very quick way to center a punch mark or other similar feature on the axis of your lathe. I'm reasonably happy with that, so now we can get to turning. I'll get down low here and show you the ichrometer view of this punch mark, and you can see how even though the stock is set off center by quite a bit, that punch mark is actually running right on center. It's not moving at all. And that's what we like to see. So we can now turn our boss, and it's going to end up centered on that punch mark. Turning this boss all the way down involves a long series of very interrupted cuts. We have quite a bit of material to remove, and this cut is so long and so interrupted, it's such a hammering on the tool that this high-speed steel tool needed rehoning about 3 times during this process. This probably would not have been a good job for a carbide. I think a carbide insert would probably have been chipped to bits very quickly doing this. You can see how much material we have to remove, and it's a long time before we get down to a continuous cut. . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . But eventually we do. Once the diameter of the boss is less than the short cross section of the rectangular section, then away we go with finally a continuous cut. This is very nice to get to this point, let me tell you. This was not a super fun operation, but it is kind of a mechanically elegant way to make this feature. Once the diameter of that boss is where I want it, then I come in and do a facing cut down the rectangular area. I was intentionally stopping short of final depth on the cylindrical passes so that I could come in and face this backside nicely. I knew with that heavy interrupted cut, I wasn't going to end up with a nice looking face on the back of this, so I did a facing cut, and this also makes sure I've got an accurate length of the rectangular section that remains, because that has to be a really nice fit on the tops of the cylinder castings. While we're all set up on this boss, I can do some drilling features that we need. I'm going to start by center drilling and drilling through for the main valve rod that goes all the way through here into the center of the steam chest. Then after that's drilled through, I need to counterbore with a larger size to hold the gland packing nut that is going to go in here. For this, I need to get an accurate drilling depth, so I'm setting the end of this drill with a feeler gauge on the end of my work, and then I add the thickness of that feeler gauge to my drilling depth. Then I measure the drilling depth with a dial indicator sitting on my tailstock quill. It's hard to see because it's behind the tool post there, but the dial indicator is registering on a toolmaker's clamp that I've clamped on the quill. This is a setup that I like for drilling accurately. Works really well for me. Then I come in and finish this with a boring bar to make sure that we get an accurate dimension and so that we get a nice square shoulder in the bottom of this hole. There's going to be a gland packing nut, as I mentioned, that slides in here. It's not threaded, it just slides in. And that holds the packing material, which is a very traditional way of sealing a moving shaft in a steam engine. This little hole here is going to get packed with typically graphited yarn or oiled hemp, things like that are used for this. On this particular model, we're just going to use an O-ring because, we have better stuff nowadays that we can use that's a lot easier, frankly. But I've used graphited yarn and Teflon cord on a lot of my other steam models. Still works just as well today as it did back in the day. Now we can bring in the other one and do the same thing, of course. The next feature is a tricky one. I'm going to show it to you on CAD. See this kind of angled hole in the back here? That is needed to bring the steam in from the steam manifold up through the cylinder casting and into the steam chest. Kozo intentionally cheats that passage quite a bit to the outside of the casting, I think because it makes it easier to drill the steam passage on that casting. However, it does mean that the passage comes up into the wall of the steam chest effectively. So he adds this little angled half circle shaped passage to bring the steam into the steam chest. Because it's not a complete hole, this would be very difficult to create after the center of the steam chest has been hollowed out. But if we do it now while the piece is still solid, then it's reasonably straightforward. So that's next. Now, when I made my cylinder castings, I had trouble finding the dimension for the location of that hole on the cylinder casting. So I estimated it from some other features, and mine is probably in a slightly different place. So I'm actually going to measure where the steam passage is landed for me on my cylinder castings, rather than use the numbers in the drawing. I don't remember actually what numbers I used when I drilled these. I forgot to write them down. That was foolish of me, but here we are. I can just measure them from the castings and it'll be close enough. I'm going to start with the piece square now in the mill and line up on that corner that I've referenced from with my edge finder so that I can measure the distance that I just measured over on the real castings. And I'm going to center drill this from this position, but we can't drill the hole from this position because it has to be done at an angle. So I'm marking the position here while the piece is square because that's easy to do. I can also swap in the other one easily because they, of course, are symmetrical on both axes, except they are a mirror image of each other, so it's easy to do the math to get the Y position of the other punch mark. I don't have to edge find again on that. Now that the holes are located, I can tear that setup down and set up for the actual angle drilling. You really can't locate the hole properly with the piece at an angle, which is why there's the extra step. I'm setting this up with some packing material so that I can clamp around the boss. I don't really want to clamp on that boss. I suppose it would be fine, but I don't know, felt weird. So I did it this way. I'll just tap that up against an angle block that's set to the right angle. And now I need to locate my punch mark that's now at a funny angle. It'll be in a different location than it was when the piece was square, even if I used an end stop or something like that. So using my pointer centered up in the mill spindle, I can locate that punch mark that is now at a funny angle. Why do we keep calling it a punch mark? It's a center drill mark, it's not a punch mark. You get it. Narrating is hard, all right? Especially doing this every single week. Now it's at an angle, so I need to next create a flat spot so that I can drill straight down without risk of the drill wandering off. So I use a 2-flute center cutting end mill for that. And then I've got a flat spot that I now have to center drill to keep the drill centered on the flat spot. Lots of little steps here, but each one is necessary. And now I can come in with the drill and drill all the way through. So this is just going to be a hole at a funny angle for now, but once I mill out the center of the steam chest, it's going to turn into that half circle feature at a funny angle that the drawing requires. Before going any further, I want to hold that up to the cylinder casting and make sure that it's in the right place. If that hole is wrong, now is the time to fix it. That looks really good. I can shine a light all the way through the steam manifold port, all the way right up into the steam chest through that angled passage, so looks good. If this was misaligned a little bit, I could drill it a bit oversize or possibly mill it or file it, do some things, but that looks good. Time now to remove all the material in the center of this thing and make it into an actual steam chest. I'm going to start by drilling a couple of big holes in the middle because we've got a fair bit of material to remove. And the fastest way to remove material is always the drill. Well, technically the bandsaw if you ask me, but the drill is the next best thing. So I'm going to drill out the bulk of it with a couple of quick plunges, and that will save a lot of time and cutter wear on my end mills. Once again, of course, using an end stop because we got all these operations to do on 2 steam chests, and they are symmetrical. The only difference between them is the location of that angled steam passage that we just did. So every other feature on these is symmetrical between the 2 steam chests. Got a lot of milling to do now, so while that's running, let me tell you a little bit about steam chests. Why are they a thing? What's actually happening here? Well, the steam chest is a rectangular box that sits on top of the cylinder, and the steam from the boiler is injected directly into the steam chest, and there's a slide valve inside the steam chest that moves back and forth and shuttles that steam from the steam chest alternately to one end of the cylinder or the other. Steam cylinders are double acting, so every stroke is a power stroke. The power is applied to one end, then the other, and during a power stroke, as the piston moves in one direction, the steam from the other side is being exhausted out the other side of the valve. So the slide valve is moving back and forth inside the steam chest and directing the steam. However, if you've ever been to a heritage park or something along those lines and looked at a steam locomotive, there is no big rectangular box sitting on top of the cylinder. You've seen something more like this. This is a later steam engine design, and because it's a later design, it's mostly what you see preserved in steam locomotives because these are mostly like 1930s and 1940s locomotives that you see. This is a spool valve. This is a much more efficient design. However, it's much more difficult to manufacture, and it has to be made to much higher tolerances. The A3 switcher is a 1910 steam locomotive design, and the early locomotives used slide valves inside a steam chest because with the more primitive and less precise machine tools that they had at the time, a slide valve is easier to make. The nice thing about a slide valve is that there's only one precision surface, the mating surface between the valve and the port face, and that surface is flat. Which means that even if you don't have a really accurate way to make a very flat surface, because the surfaces are flat, and one of them is typically cast iron and the other one's typically bronze, the 2 surfaces are going to run in over time and the seal is going to get better and better. Furthermore, the reason that the entire valve is inside a steam chest like this, and the entire steam chest is at regulated steam pressure, the pressure of the steam in the chest actually presses on the back of the valve and helps create a better seal. So the steam pressure is actually forcing the valve up against the port face. It's a very clever design that, while it's not the most efficient design, it compensated for the limitations in the machining technology that they had at the turn of the century. And slide valves were used on steam locomotives well into the 1920s, maybe even later. After that first pass with a large end mill, I came in with a smaller end mill because the drawing actually calls for a smaller corner radius in the corners of this. So I roughed it in with that larger end mill because that was quicker, and then I'll come in with a smaller diameter end mill and plunge it into the corners to tighten up those radii, and then I did a little finishing lap all the way around the outside of the steam chest to clean up the cut of the larger end mill and also to leave the correct corner radius in each of those little corners. Now you can really see those angled steam passages coming through as well. It's kind of a neat feature. Next up is the bolt pattern. This is a very easy set of drilling operations using the DRO. I do have to be careful though because, again, in my modified steam chest, the outside dimensions of the steam chest are not symmetrical with the bolt pattern and the inside cavity. So I'm using two different reference lines. The center line of the inside cavity is still in the same place, so the function and the bolt pattern on the steam chest are unaffected by my change to fit with my new cylinder castings. However, I have to be careful which references I'm using so that the bolt pattern lands in the correct place. If you look very closely here, you'll see that the bolt holes are very slightly closer to the right side of your screen, that edge there, than on the left side. That very subtle difference is the modification that I made to fit my undersized castings. It was an easy change to make on paper, but when it comes to manufacture, that's a very easy source of errors. So I had to be very, very careful to make sure I was always edge finding in the right way and using the correct references for all the different features on the steam chest. Now I can set them up sideways. I'm using the edge of the fixed jaw for an X repeatability reference, and I'm center drilling, and tapping for a little set screw. This little set screw is what holds the gland packing nut in place on this model. Again, typically these would be threaded or have bolts on the sides to clamp down on the graphited yarn or whatever the sealing material is. In this case, Kozo just uses a little set screw because the quote-unquote sealing rope is just an O-ring, so it doesn't need a whole lot to hold it in place. This setup repeats really beautifully as well, so the other steam chest was very quick to do the same way. Now, with the steam chests done, it's time to make the steam chest covers, which sit on top. Conveniently, a viewer recently donated a bunch of brass plates, one of which is the perfect thickness for this job. So I'm going to cut my two rough blanks out of this to make the steam chest covers. Once again, over to the bandsaw for that. These two steam chest covers are identical, so I'm actually going to super glue these two blanks together, and I'm going to make the steam chests entirely as one unit. This will save me quite a bit of time and tool changing and so on. So with that glue cured for a good 10 minutes under clamping, I can set this up in my milling machine and proceed to clean up all the edges and bring the sides of these plates down to dimension. Once again, ultimate perfect squareness, not actually important here. I just want all the edges cleaned up and brought to dimension, so I'm cheating, creating two parallel sides. Once the blanks are both at their correct width, then I can set them up horizontally, machine the ends, and proceed from there. I actually didn't machine the top or bottoms of these. Theoretically, I should at least machine the bottom because that is a sealing surface. However, the stock surface is actually very good here, and there is going to be a gasket, which I think will take up the little bit of variation that the factory stock has in it. I didn't want to thin these out any more than necessary, so I'm going to try it as is. If they leak underneath, I can always put a little RTV in there, or of course I can always just take a skim cut on them if I need to, but the stock looks really good, so I think it'll be okay. With the stock squared up and brought to size, then of course I do the bolt pattern here as well. These are through holes, so there are screws that go all the way down through the entire stack of steam chest and steam chest cover into the cylinders to clamp everything all together. On the prototype, these would probably be studs, but there isn't really room for that in the model, as you'll see, so Kozo did it with screws. And in the center of both of these, there's a small threaded hole that receives a stud, and this stud is used to clamp a decorative cover over the entire thing from above. Now it's tricky here, the bolt pattern is not centered on the outside edges of the piece because of course there's an asymmetrical center line for the bolt pattern, just like the steam chests. However, I do want these studs to be centered on the outside diameter of the piece because then the steam chest cover that goes over top of this whole thing, the decorative cover, will have the mounting bolt nicely centered on it. That'll all make sense in the future when you see how it all goes together, but it's just one of those little tricky details that would be very easy to get wrong if I wasn't careful. Then I come around with my countersinking bit and I countersink all the holes for the top steam chest cover. This is one of the two that are still glued together. These screws need to be countersunk so the decorative cover can sit flush on top of them. Then I can flip the whole assembly over and countersink what will be the top of the other steam chest cover on the other side. I just have to be careful to flip the part assembly on the x-axis because the parts are symmetrical on x, but they are not symmetrical on y relative to the reference that I used because the center line of the bolt patterns, remember, is not the center line of the material from the outside edges. These are the little things that can scrap parts for you if you're not really paying attention. Now we can separate those parts, which I do by soaking them in acetone for a few minutes. I used to use heat for this, which also works fine, but Honestly, the acetone works just as well and doesn't discolor the parts, and you don't have to get out the torch and stuff. So the acetone seeps in there and breaks the glue. Then all these pieces go into the pickle bath to prepare them for silver soldering. The little threaded studs that I mentioned that go in the centers of these covers need to be silver soldered in place because of course they will be at steam pressure and steam temperature, and so we have to make sure they don't leak. The studs themselves are just 3/48 screws that I cut the heads off of and cut to length. Nothing fancy there. Then off camera, I cleaned everything up and rounded all the corners with a file to match the steam cylinder casting, which has rounded corners, as you may recall, all the way around. So these are the final steam chests. You can see how those angled passages worked out. Those are pretty neat, I think. Kind of a tricky feature there. And those are the covers, as you can see. That's how they are installed. You can see the studs and how they sit on top of the cylinders. Let's get this all mounted on the locomotive and see how it looks. Later on, of course, I'll be making gaskets to sit between these two layers, but for now, we'll just clamp everything together dry to make sure everything fits, and we can make all of our mating components. We'll get to the gaskets, and it's all going to be powder coated as well later on, but one thing at a time. There it is, the final steam chest, waiting for its decorative cover that goes over the top, and that's going to hide all those modern machine screws so that it looks like the real thing. But so far, so good. I'm pretty pleased with how those came out. I'm certainly enjoying making all of this running gear. It's a lot of fun to make this kind of stuff on the locomotive. Thank you very much for watching. Thanks to my patrons especially for supporting my videos every single week. You guys are really making this happen, and it means the world to me. With that, I will see you next time.